So let's see. We'll wait for everybody to join the YouTube stream again. So just a second, I will tell a couple of things in Latvian. Okay, we have 13 people joining. Okay, so please, please use the chat again. So, just a second. So, let me tell a few words in Latvian first. So, pirmkārt, mums šajā kursā ir kaut kāda daļa ārzemju studentu, tāpēc mēs viņu taisīsim angliski, bet jūs droši varat jautāt visus jautājumus latviski, un arī tajās reizēs, ka es esmu jūsu lokācijā klātienē, tad es varu palīdzēt arī atbildēt un visu uz vietas arī programmas kodu un pārējo pārbaudīt klātienē. Bet tad vēlreiz, varbūt to es uzrakstīšu, ja čatā kāds pievienojas vēlāk. Tātad course will be held in English. Tāpēc mums termini arī lielākā daļa ir angļu valodā. Man ir citu terminu vārnīca arī latviešu valodā, tā kā jums tos vajadzēs. But you can, kas tur rakstīts? Tā, lekcija ieraksti. Jā, lekcija ieraksti ir pieejami. Tu jau tagad esi laivā, tas nozīmē to, ka šīs te būs pieejams. Course will be held in English, but you can ask any question in Latvian. I will be joining time to time. Also physical location. So to help in person. Otherwise, follow Moodle, YellowRobot. So that's my Moodle, because the university Moodles have all sorts of limitations. For example, I will have automatic marking of the homework, so on. Follow Moodle, otherwise follow Moodle, and the right email. Right email evalds so jā, šodien, ok, cool. Visi jautājumi der, rakstiet iekšā. Ja jūs kāds kaut ko nepaspēsiet, if you are, like basically, if you are not able to get follow the whole course today, you can follow later in the video as well. But basically, these courses will be every Friday 9 to 11 around that time, not more. So, but there will be materials to work also on your own. When I will be in physical locations, I can help to do these practical works as well. But also, we'll do this online. So first of all, we'll do a little bit of introduction, the course plan, and so on. This will be till the December, basically the new year, and at the end we will have the paper exam. So basically, from my previous experience, basically the only way how we can then judge if you understand anything that we cover here, we'll have the paper exam where there will be test questions, there will be practical problems, and so on. So on e-pasts. I have many emails, but you can write to me. But anyway, so email will be provided inside the Moodle. There is the email. So because if I write here in the chat, it will not work. Okay, so that's that. Okay, let's do step by step. Also, we'll do this presentation, as I said, of what we are covering here and what are the opportunities of working together. This, by the way, this kind of course is the course which I know a couple of companies pay employees to go there for like even tens of thousands of euros. So it's kind of valuable, but it depends on how much you yourself want to get out of it. So we will see to that. Var aiztaisīt durvis kāds, ja? Izstāst, ka tur nebūs vairāk neviens. Tad just a second, we'll get there. Yesterday, one of my production servers crashed. That's why a little bit out of the order, but we'll get there. Just a second. Okay, let's do step by step. So first of all, the contents of the course. Where is my typora? Typora. Course. Here it is. Okay, cool. So there will be also other. There might be, actually, I'm not sure, but there might be also another other lecturers. I have some of my fellow researchers who are also very good. So we'll start with the like just an introduction of the deep learning and AI techniques and models, and then like research opportunities and how we can work together, and then immediately we will start working on a real problem. We'll make an Asteroid game. Why exactly Asteroid game? Let me show you. Maybe you even don't know what it is. So this is like very old game. So Atari Asteroid, I think it was called Atari Asteroid, and it is makes sense why it is why it is related to this course. So it's not like, okay, this is not related to our course. Definitely, that's funny. So let's see, can I get? Okay, let me get these. I don't have subscription for YouTube, so okay, let's show that a second. So then we'll have the matrix transformations, linear algebra basically. And then we'll have the inverse kinematics and basically calculus, partial derivatives. Everything will be super application oriented. So basically, we don't talk about theory, we try to do things in real. That's why actually I choose this Asteroid game. Okay, it forces me to watch this advertisement. Yeah, every time when I close. Okay, so because the Asteroid game, I think it's a great way how to learn all of these basics that are necessary to start building these artificial neural networks, basically. Oh man, let's see. Does not expect it to have such an advertisement here. Okay, cool. So this is the Asteroid game. Right? If nobody, hopefully you have seen sometime. So basically, the idea is that every single like this graphical pixel there, like the triangle of ship and asteroids and so on, and this spaceship, everything is drawn by vector graphics. And basically, what it means is I can define ship by, let's say 1, 2, 3, let's say 3 or 4 points, right? Depending on how you want to draw it, and then display this on the screen, and then like with the linear algebra, move around it on the screen and do all sorts of things. So, and basically this is also really relevant because the linear algebra and this kind of mathematics and also calculus is basically the same mathematics used in graphics rendering, like even for the 3D games when you have triangles, you know, from the triangles 3D games, right? And basically the same mathematics applies for the artificial neural networks, and that's one of the reasons why NVIDIA GPUs and the NVIDIA company itself started working on this direction, and now they are like $6 trillion company and basically no other GPU manufacturer can do what they can do, and basically this is very related. So really advising to do this. Okay, so we'll do that. Then afterwards we'll have the actual artificial neural network tasks. Then for the classification, the regression, then image tasks, right? Image classification tasks. Then the deep metric learning. Then segmentation tasks. Then time series. And time series also will cover transformers and GPT models. So GPT-4 and any kind of GPT models, this is actually nothing. This is really simple models. They are not like out of this world. So any person with a little bit of mathematical knowledge can build GPT-4 basically. So we'll do that. And then afterwards, the image classification also with transformers, then reinforcement learning, which is like playing computer games automatically and do very complex tasks, and then deep metric learning generative tasks. So maybe we'll change something along the way, but this would be the way. And then there will be a homework after every session. That is for your own benefit. If you don't do this later, it will be harder for you, much harder. Also, we will examine the homework in the following session, so everybody can learn from that homework, see, okay, this was good, this was not good, but basically the main idea is that everybody should submit homework till the next session. You will get a somewhat good grade even if it's wrong, but if you don't submit it, you will get 0, and then basically you will not be able to submit it later. If you submit just the empty stuff, then you also would get 0, or copy just some colleague. That's also no use for us. Okay, so that's that. So that's for the course side. Let's jump into some interesting slides, and then we'll start actually doing some coding today. So please, maybe I should show that as well. While you're looking at some slides, you could start preparing your environments. Just a second, if you're not done this already. So environment. There was actually in Moodle task 1.2 where you should prepare the environment. So let's see. So you should have installed on your computer Anaconda Python, right? Python 3 something, Python 3x. You all have your own computers. Okay, great. So that's that, and okay, hopefully I can make. So in this platform, I should be able. What? That's interesting. I was sure that I was able to write multiple lines. Okay. Anyways, so Anaconda or micro, Mamba, micro, conda. These other ones are basically, you can choose any of these, but these other ones are faster. Micro, conda. I myself prefer micro conda, I think. So that does that, and then also you need some environment where you will write the code. So you have options: the PyCharm, which I believe is the best one, and then also you can have the oh man, wait, sometimes works, sometimes doesn't work. This is weird. Okay, I just this year started using this Whiteboard platform. Previously I was using Jamboard. So PyCharm, Visual Studio Code. With Visual Studio Code, you would need to install a lot of extensions to make the same thing as in PyCharm, but it's doable. And what else? Like, yeah, and if nothing else works, like if you don't have anything set up today, then let's please use Google Colab. So Google Colab, I will open already this Google Colab. This is the online Python environment where you can write code directly in your browser, but you will not be able to do this for the next lecture. For the next lecture, you will not be able to work here because for this computer game where everything moves around, this is not doable in browser. So yeah, these are the things you need. So please, if you have not set it up before, please do this now. Meanwhile, I will just a second get ready the presentation. Okay, maybe there will be some Latvian words, but we'll live with that. Just a second, my computer is working against me this morning. Okay, we have something. Yeah, this is not too bad, everything will be here. Okay, cool. Okay, let's do this. So, okay, this is this. Let's see, presentation, window capture, keynote. Okay, cool. Yep. Okay, so yep. So there's a lot of opportunities with AI. This will be a little bit difficult to do this online, but we'll have some questions here as well. So yeah, I myself associate professor, lead researcher, and entrepreneur. So we're making AI products for like telecoms, Tele2, TET, large corporations, BTA, I know, like banks, all sorts of, also like German, American companies. And that's one of the reasons why I also will not be able to do this next week in person, because I will be in USA and we'll going there with the president's visit there, Latvia's presidents, and there is the we also have Latvian Artificial Intelligence Latvian Association, MILA, LV, so that's something we also do. Okay, so and let's start by getting what is the AI at all in this sense. So maybe some of you have ever seen this presentation. Then if you have seen it, then definitely also participate. But otherwise, let's see. So this is the I saw this, found this actually on internet and social media. This meme, this metaphor, right, of what AI is. And to understand what AI is, we need to understand what Scooby-Doo is. Do you know what Scooby-Doo is? You know, yeah, okay, let's check if you know. So there is the Scooby-Doo team, and then there is the dog Scooby-Doo, and then there is the ghost or octopus or monster or Frankenstein that is like scaring away, let's say, tourists from some place, because there is the gold digger here, right? And then at the end, the Scooby-Doo team captures the monster, ties it up, and then takes off the mask. And what is under the mask? If you know Scooby-Doo, you know what is under the mask. The villain. Villain. Is the villain the monster or person? Human. Yeah. So the under the mask is human. So you know Scooby-Doo. That is the first thing, good thing. So, okay, so, and then here, what we have is the, I will have also a question to the online audience. So here we have the monster, the advanced AI, yeah, so this Sophia robot, it's actually like that, so that is one of these robots, and it could be also ChatGPT. We need to actually think of it as ChatGPT. So, and it's now, they say, okay gang, let's see who the advanced AI really is, and then they take off the mask, and under the mask, if you know, we are all here smart people, so what are those? Yeah, and how you would explain it to some person who don't know what it is? What do you think? What it means?
It's like going through conditions
and
checking.
Yeah, so it's like a computer program with lots of rules. Yeah. So okay, let's start by first thing first. So, is the metaphor understandable? Yes? Okay, good. So then my question to the online audience and also here, so let's see, so let's first I will formulate a question for the online audience. So let's see, so if you agree, then plus, don't minus. Please type in the chat plus minus if you agree or not agree, and if you agree, then please raise hand. Don't agree?
Agree or not.
on metaphor.
Ah.
Yes?
No.
No? What about the online audience? Please type in. It's not difficult to type in. Okay, somebody typed in plus. Okay, good. For some specific questions regarding courses, please write to me an email. I will definitely help out to understand this. As I said in very beginning, the goal here is to basically achieve, to get you to the good point with these technologies. If you don't like these things, which I will show and we will learn, then I will not push you to have a bad grade. So that this is not something, so I don't, there's no point for me forcing somebody to love mathematics. So if it's not the thing that you like, we'll find some way. But otherwise, let's keep working with this. So I see some answers in the chat. Not everybody, but somebody have answered. So it's like 50-50 in the chat. So first of all, like in the chat, please write why you disagree here. Some statements why you disagree, and here on the live audience, like what do you think this is not the case or the case? Statistics for I already biased you in the very beginning by starting telling you mathematics.
Es statistikas man Liepājā, es vienkārši biju kaut ko, nu, tā kā pasaka, biju
manā kādā?
Nu, tā kā nevis lekcijas, bet tā kā jau klausījos. Tur vienkārši tā matemātikas funkcija kaut
Jā, ļoti labi. Ne, tas ir forši. So, yeah.
Bišķis puses, es vienkārši nenokādu.
Tu nenokādi? Interesanti. Okay. Interesting. Okay. So the online audience, I mean the live audience, they had good kind of directions. So some of people have already learned a little bit about the machine learning and deep learning, and they say that basically there are some reasons, but I don't see actually in the live audience nobody dares to write why they disagree. Hopefully they will. But some other people say that they have seen already some implementations, and the real implementations are a little bit different. So let's go in. So first of all, if I ask this question to the Riga Business School for the business people, then everybody agrees. Like there's rarely somebody who don't agree. They all think that the ChatGPT, the advanced AI, is based on lots of programming rules and so on. If I show this, as in this case, with the master students, right, and then basically, especially in mathematics, then nobody agrees. That's not interesting question, but okay, we'll see. So aren't GPT just predicting what the response of the question would be based on commonly? Okay, that's excellent. So basically, thank you for engaging in the online chat. So the okay, so we will get to the GPT models. You will be able to, if you are willing, you will be able to write your own GPT model. So, and you will see that GPT models are not trained to answer questions in that way, like with the most commonly used words. It's a little bit different, but still, it is the correct direction of thinking, that there is some kind of prediction, right? And it's kind of difficult to predict things with just rules. And what it really is, it is nowadays everything is based on deep learning. So it's not like learning underwater, don't worry about it, you'll not do this. But what we have is this, and as you said correctly, right, you have seen something like that before. So these are the mathematical equations, and this will be bread and butter of this course basically, but don't worry, like, if you would see this equation just on your paper, right, and you just need to write the answers and so on, like to calculate derivatives, like do operations with it, then it's boring. But in this case, this will not be boring, because you will not have just equations. You will have actual problem. Like let's say classify dogs, cats, like segment out cars or something like that. And then if you have real problem, you have equation, and then you have real answer. So that, I think that's quite exciting, rather than having like just you do matrix multiplication. Why I need to do this? Now you will see why you need to do this. You will understand exactly the same. This thing affects this thing in this way, and that's why this works. So, and here, this is one of the models equations. So that's one thing you please remember. Don't call AI and especially deep learning techniques as a model, as algorithms. They are models. So basically, this is mathematical model. There is a function. These are not programming functions. One time I said, like, there's a lots of functions. One guy like, I know what is a function. No, this is not a function, not programming functions. So these are mathematical functions. And what you have here, the X is what Sophia sees, the robot sees, right? The ChatGPT sees the sentence. And H in the bottom is what Sophia does or the ChatGPT does. Like it says, it's a probability distribution. It says, hello, 90%, 10% goodbye, 0% go left, 0% go right, and so on. Like like all sorts of tokens. You can have any kind of response, any kind of input. You can these models means that you can have any kind of input, any kind of output. It's just need to configure right way the equations. And then you have the coefficients, right? Coefficients are called in deep learning weights and biases, W and B. And they're these these stars. They are actually in this case dot products. So this is matrix multiplications. And you have the method how to train this. This is called the stochastic gradient descent and backpropagation algorithm, which was invented by Geoffrey Hinton in early 90s, basically late 80s, early 90s. And equations like these were first popular, mostly used by some researchers like Yann LeCun, who is now the Facebook Meta AI director. And by the time when he used this in the early 90s, everybody was laughing at him. Like nobody took seriously this. They said, this is the wrong way. You need to have the manual features, how they see the corners and things like that, and then describe these as patches, and then do the cascades of rules, and then have the answers, or do the some vector machines or some support vector machines or something like that. But at that time, this was a different story. At that time, there was very little data. That time, like early 90s, there was 200 megabyte data sets of handwritten letters. Right? You will also be able to work with that data set. Nowadays, you have, let's say, 200 gigabytes of images or even terabytes. And basically, you also have a huge computing resources. This is the picture from RTU supercomputer on Keepsell. There is a lot of 800 video cards inside there. So nowadays, if you want to know, there is 800 and 800 NVIDIA video cards with about 80 gigabytes of RAM on each of video card, and then you're able to train these models. If you don't have that kind of resource, it's very difficult to train these models. It's super slow. That was one of the reasons why in early 90s nobody believed this, because it would take 10 years to train some simple model, right? So this is not feasible. But then in the middle we have this mathematical equation. Mathematical equations have been developing. In last 10 years, they have changed a lot. So, but the same equation from early 90s works great today. Basically, you can get even 99% accuracy. But with some of the new equations, you can do some even better things, which I will show. So what happened? Basically, huge data. Huge compute resources, the same equations, put them all together, and you get from unstructured data, structured data. So this is a paradigm shift. This changed last 10 years. Basically, in 90s, you would say in the machine learning, junk in, junk out. There is such a saying. If you have a bad data coming in, you will get a bad output. It's nothing good will come out. But in nowadays, it has been changed. Nowadays, we have very powerful deep metric zero-shot learning, representation learning models where you can put in unstructured without labels data and get out structured data with about 70-80% accuracy of human terms. So it would put together, let's say, all of the horses, all of the cars, all of the water like ships and so on, things. So, but if you have labels, on the left side, right, and then on the right side you would get 99.9% accuracy or even higher. It will never be 100 basically. But there is also one thing to notice, that even human beings are never 100 basically, especially for intellectual tasks which are not like very deterministic. So that's that. And what you can do nowadays, you can literally, I will show some examples in a minute, but you can basically literally see how balls drop with camera and discover physics laws. You can model fluid dynamics with deep learning. I have students of mine, and we actually published some papers basically with that student where like instead of Navier-Stokes and all sorts of differential equations, you can model physics with deep learning better than with the equations, because the equations of physics is actually like approximation of the reality basically, and this is made by humans, like using all sorts of methods, right, from existing equations, developing new equations. But with deep learning, we can find out that either we can create better equations or we can model the whole process better. It's being used in computer graphics for simulating how light is like if you look at NVIDIA's last video cards, last like frameworks, they model ray tracing the illumination of light using deep learning nowadays, instead of using like classical methods. So, and the history is, by the way, online audience, if you have questions, you can write in, not questions about just some technical, like course things. You can write me an email. That's, as I said, my goal is not to give bad grades. My goal is to have the people who can use all of these things get to the highest possible level, and other people who don't want to use these things to get a basic understanding. So basically the early days of deep learning AI. So it was 1950s. There was the Rosenblatt and colleagues from America. They promised artificial brains, artificial neural networks. They did it with different mathematics than nowadays. This breakthrough of mathematics, actually, the serious things happened after the second AI winter in these 90s, early 90s, late 80s. So in early days, in 50s, they promised these brain-like systems, perceptrons. It did not work at all, didn't work. And that's why there was a first AI winter that said, like, this will work, this didn't work at all. So the second part was the fuzzy logic, expert systems, and these kind of rule-based AI systems. Basically, there was also all sorts of morphological systems with tables, graphs, and so on. So, in that time, basically, this is the picture on the left. I actually have a, yeah, so just a second, I will take off my video capture screen here, because then you don't see the picture on the left, right? Okay, cool. So on the left, MIT, a self-driving car. When you go into the room, the car drives over you, because nobody programmed that some kind of cowboy walked in the room, right? So this doesn't work. So, but then on the other side, there is Tesla's full self-driving car, and this is actually kind of important, because if you look up the Tesla's AI director for many years was Andrej Koparty, who was the first one who in the like 2000, let's say 14, 16, about that time when this all exploded, was making these courses and these methods known in Stanford University, and he's one of the kind of leading experts in the field nowadays. Like there's old guys like Andrew NG, who is also good, but Andrew Kaparti is the kind of from the new guys that know these things much better. So and basically from what he is telling and what I'm seeing from the models, there is no reason why these systems will not be used very soon between the cities to automate logistics and things like that, and even in the cities. If you already see the statistics from this full self-driving cars, right, when they drive and take over, the human takes over, it already seems that basically humans do more errors than machine do. Any time when like this full self-driving car goes something stupid, right? Then there's like this is bad. Nobody can use it, and this happens like one in like I don't know 100,000 times, right? So, but this is the thing that where we are going, and nowadays I don't see a reason, and also I will maybe share some statistics with you why we will not have these systems widely used very soon. So. So this is like a fourth industrial revolution. If we look back, then there was the first industrial revolution by using the steam, right, and oil and things like that. Second, with using the electricity, and like Ford with these assembly lines. Then third, when we started using robots and automated assembly lines. And nowadays the fourth is very different from the third. So the third generation robots were like you programmed with Robot Studio to do one thing, and that's one thing. Nowadays, these systems can work along humans, and also if something changes in the environment, it can adapt very easily without reprogramming and so things like that. So, and this is like the new electricity, and this is like if you look back like in history, this is the World Expo from 1893. Like the first time when electrical lightning was used like for this World Expo. Before it was gas lights and candles. And now 100 years later, no business works without electricity basically. And this is the same, you can think back of internet, right? No business works without internet, without now even like mobile apps, smartphones are often very serious part of the business. So the same thing will happen with AI, because this is able to automate any intellectual process, basically where you cannot describe it in rules, but you have data. If you have data, you can automate it. So, but you need to also know how to use it correctly. So there are some examples. For example, the left side, this is the PayPal chatbot before ChatGPT. This is kind of built on old methods how to do this. And if you write that I got scammed, it says great, right? Nowadays, these chat models, which are based on language models, they would never do this. Like it's not hard to make it so that it would respond correctly. So also another thing to notice, I have met over the years many times some kind of developers who take from Hugging Face or from, let's say, the GitHub some model, run it like YOLO model, make some kind of project, and then happens like this, and then they say this doesn't work, right? This is like just all like not true, it doesn't work, and so on. But it's actually what is the reality is that you will see very soon in this course that you need to understand how these models need to be fine-tuned, trained, and as soon as you know exactly how to do this, you will never have these kind of problems. So, and you also please don't use these models for things you cannot predict, like for example, Bitcoin price and some I don't know, other kind of stock predictions. So because even though for the historical data you could get something that gives you some reasonable accuracy, as soon as you will start to apply it in the real world where there is like the history really a little bit kind of repeats, but not as much as people think inside these kind of you know, unpredictable processes. So if the process is repeating, predictable, described, even if it's not repeating, but it is very well described, for example, you can use these models. But if it's very random, then better not. Also, this is another example. So this is a cool company from Estonia, Starship. They are building 10 years these last mile delivery robots. Have anyone seen that? Those or no? So, videos, but they actually, you see there's like Soviet buildings in background and then the robot drives, or it's also the same robots are in San Francisco. So basically, well, the story with this is that this is the 10 years, 200 million to make this kind of platform, and it's mostly still remotely controlled, but I believe they also make a lot of automated things there. So, but the thing is that why I'm showing this is that AI, from all of the data that I have seen, is used first of all for high-paying creative jobs, not for low-paying jobs that nobody want to do. Basically, the thing is that this machine costs like tens of thousands of euro, but basically some guy with a bike costs like €2. So this is the thing that to understand that deep learning and these AI models enable businesses and companies to automate very intellectual work where it's very expensive first, and then you go to these cheap ones. So I'm showing this because like sometimes startups or companies think, okay, let's automate something that I don't like to do, but there is no money there. So it's always everybody is trying to automate things where there is most money there, and that's why I also seen some time ago one post in LinkedIn where there's one woman who was writing blog posts wrote that like I don't like AI taking my job of writing blogs. I like to write blogs myself. I want AI to pick up my dirty dishes in home, but this will not be the case. The blog writing will be automated, that's it. So basically there will be needed, as previously 10 blog writers, now you need 1 blog writer. That's just reality. So, and this happens basically. So, the technologies, we have the overall artificial intelligence, we have expert systems, fuzzy logic, those are the old methods, then there's 90s methods, decision trees, clustering, some basic classifiers, and then there's the new methods with deep learning. In time series we have ChatGPT, which we will do. With Gen AI, we have generative models, fusion models, all sorts of models, which we also might do or will do. We'll see if we can get there. So how this is being trained? So you will also train a lot of models. It's not a model train, but it is something like that. You have data set. You split data set in 2 or more parts. Often you split more parts than 2 because it's important actually to do that. And you use one part of data to pass through the model, the mathematical functions. And these boxes, in our models we also will use a lot of boxes. These boxes means the mathematical functions, you pass it through. You get the, you also need to have some hyperparameters, like one hyperparameter is how many these boxes I want. Like I have like, let's say this structure and there is written 12, so let's say 12 boxes or 8 boxes, maybe I need 100 boxes. So this is hyperparameters. And hyperparameters need to be searched. And each time you search hyperparameter, you need to train new model. And training model means that it will find the kind of optimal or suboptimal, close to optimal solution. It will automatically, using the mathematics, change the coefficients so that the output is the best it can do. And by the way, here you will see it later, but the optimization here is the same kind of optimization like lightning strikes. Like lightning strikes with the least resistance. If I pour out water, it pours to the least resistance. The same type of mathematics here. So it will always try to find the simplest solution based on data. And then at the end you validate it to test if it works on data that model has never seen. If it doesn't work, then there's two options. One option is that maybe you learned each sample by heart, like remembered each sample, which is overfitting. Or another option is that there is not any kind of pattern or logic behind it. It also can be the case. But you will see that in second. Not second, but soon. So, and this is being done on GPUs because it's very, very slow. Okay, so this is this. Let me jump into the another presentation with some good examples. So, okay, so I'll show you some other research we have done, and then we'll start doing Python with the second part. Okay, no questions here, 20 people, no likes in videos. Okay, let's see if somebody start liking video. So, okay, let me share some of the research we have done so far. By the way, anything that I show you, you know, like it's not something that other people have done. I will try to only show things which my team has done. So, for example, here. So this is the one of the papers we published some time already ago. Is the models that learn how to play this annoying game perfectly. You know this game, right? You need to, yeah, Flappy Bird. Press a finger and then like smash your phone, right? Like it's like super annoying game. I recently saw that one guy was made like a huge iPhone and then played with Flappy Bird with the palms. But basically, so Flappy Bird. The way how this works with reinforcement learning, which is the latviešu valodā stimulētā mašīnmācīšanās, reinforcement learning works by having rewards. So I get a reward from the game. It says that let's say you did good, you did bad, or you get the score. This reward can happen also at the end of the game, not every time something happens. And then deep learning model learns how to achieve the highest score possible just using the inputs that it has and to do the output. So basically what it means, we could build a system that films with a camera the Flappy Bird artificial finger, and it can learn to play this perfectly just with that information. So, and also this is not a black box. There is also kind of myth. And this is propagated probably by the people who are not experts in deep learning. Basically, deep learning nowadays can be made quite white box. So it's not like that there's a huge artificial neural network and you don't know why it does things. You can actually, even nowadays, change the way how language models respond to specific questions by changing the weights inside the model. So there's quite a big transparency. So here's the example on the left, before training, on the right, after the training. And this models the locations of the bird and gives the predicted rewards. So basically, you can see that it understood that it don't need to go to the pipe. There was also a bug in this game, basically, that you were able to fly over the pipe, and then there was a green part in the top part. So it's kind of this is important thing to know. So that's that. We also can do the same for the 3D games, right? To evade enemies and to attack enemies. So there's, but nowadays there is even nicer 3D games that you can play. The labyrinths. In a huge labyrinth, find the exit door, the red door. And here also, you want to have transparency. You want to understand that the agent, your model, is paying attention to the red door, not, for example, to the floor. And you always check these things. There's also a great example how deep learning works. Here is the popular image dataset, Pascal VOC. And here on the left side, you have the images of horses, and this is there is in that data set there is one photographer that always photographers horses. She don't make photographies on other things, just horses, and she always adds her like the signature. And now let's make an artificial image with the like meadow and Ferrari, and add the signature. And it thinks that this is a horse, basically. And if you do actually the analysis of let's say class activation maps, you will see that the model thinks that this is a horse because of that area. And you already see that this is the signature that's making it think like that. And this is very logical because the model is not like a human. It don't understand like the whole embodiment or reality. It just understands the data set, and it sees this is the simple way how to detect horse. If there is a signature, it means this is a horse. So basically, and what you would do then is to check your data set for these kinds of biases, make sure that nothing like that exists, check the class activation maps, and only then deploy in the production. But I would say that 99% of AI solutions nowadays still don't do proper analysis, and then strange things happen. But still, this is kind of powerful. So we also have one other research with curiosity models. So basically, there is a huge labyrinth where you need to find the exit, and you need to have some kind of intrinsic reward mechanism that moves you forward. And the funny thing is, if you put inside there the TV, then it starts watching TV, and it fulfills the curiosity and don't move anymore. But then when you start showing the same things, it becomes bored, and then it starts again moving around. But it's kind of funny that with very simple mathematics, you kind of simulate the behavior of small children, even like because they do the same thing. But this is just like simple mathematical solution for the curiosity in reinforcement learning. There is also classical models, like for example value iteration. I think it was value iteration models. So that they are used for optimal path finding. If I put some point in the map, I want to find the optimal path to some other point. You can use also some suboptimal solutions like Dijkstra or A star, but this is the optimal solution. So you can also use this to change this classical kind of artificial intelligence method into deep learning. And if you change it to the deep learning method, you can make it work like 10 times faster, basically. So it's kind of really interesting that classical algorithms can also be made with deep learning to work much faster and have better accuracy. No, maybe accuracy will not be always better, but they will be definitely much faster. So also another research we had about curriculum learning. So this means like in school, you give all of the hard tasks together with simple tasks, or you split out simple tasks, then hard tasks. And if you split out, then actually these models can learn better. So this is that. There is also a cool thing you will understand later, is that there is a lot of zero-shot models. Basically, you can have, as you see here on the, let's say on the, do we have the same things? To do the same cars? Okay, there's no new cars here. But basically, you can have models that cluster together by the semantic information, by the meaning of the image. So if I would here put a bicycle, it will automatically understand that it is closer to the bikes, to the motorcycles. So these models can work without training. Maybe I have another picture here. Yeah, so this is how Apple Face ID basically works. So you have Apple Face ID is not training to recognize your face. It's already trained model, so pre-trained model. And the pre-trained model, which has never seen your face, is able to classify your face anyways. So this is why I'm told in the very beginning that there are a class of models that are supporting zero-shot, few-shot learning. So it's based on deep metric learning, where you can train model to understand particular domain of knowledge, and then later you can use this domain to classify things which has never seen the model. So it's super powerful. Basically, you can basically structure unstructured data with these things. I know already some companies that are working with hospitals nowadays, where they use similar types of things to structure unstructured data. Like previously, some human needed to understand what means this. Now the computer understands before the human. So that we also have published a couple of models in Hugging Face. We have the largest Latvian language dataset for the semantics. So physics, right? This is the physics research where on top we have ordered so the simple differential equation method, and in the bottom part you have deep learning method, and this is the double pendulum system ordinary differential equation. So double pendulum system, and you release the system and it's a chaotic system, but the deep learning was able to predict even 3 seconds ahead, which is kind of crazy because no differential equation like vector field methods or something can do this. So then also for emotion classification and style transfer, these kind of CycleGAN models we can also do in our course. So for audio generation, for speech enhancement, we've worked with microphone manufacturers. For speech to text, text to speech, there's basically if you want to start yourself, Whisper models gives you kind of good baseline, but with our models we have reached better results. So that's that. Okay, I think for the introduction of just the basic things, it will be enough. So now we could start moving towards actual programming and getting us ready to the level we need. So let me quickly open PyCharm. Please, you also open some kind of environment where you can work, and if any questions in the chat, I will try to look up that as well. No questions. Okay, we have 1 like, thank you. At least hopefully nobody already fell asleep. So wait second. Tūlīt mēs dabūsim visu online. Just a second. So new Python tas būs live. So uztaisīsim failu. Okay, this looks something like this there. So we'll start quickly with some Python basics, and then we'll move into more advanced things. Oh wait, before I jump into the Python basics, I actually have a good question which I want to always ask, and if you will answer in particular way, I also have interesting way how to handle it. So PyCharm, okay, cool. So this is the Python environment. Cool. Cool. Okay, so first question I will ask in the live audience as well, but definitely for the remote audience. So please rate your Python knowledge. So from 0 till 10. Please write in the chat how well you know Python in your opinion from 0 to 10. What do you think? 5? Okay. Okay. In the live audience we have 5, 6. Okay. We have 1, 8. Okay, that's great. That is excellent. We'll wait, but don't be ashamed if you have 1, 0 or something. I need to understand the situation. We also will see very fast if like the level of understanding, and then we'll adapt to that basically. Meanwhile, while we're waiting for answers, though, you can just start typing, getting some basic thing like hello world. I think this was also for the first task in home. So you see we don't add at the end any kind of these semicolons or something. and you don't, and in Python we don't care if this is a single quote or double quote, and if I run it, it should work. Hello world. So let's get that one working, please, also in the live audience, and we'll go quickly ahead. Quickly ahead, and we'll wait for the online audience. Just a second. Okay. So we have that. Let's see. Okay, so we have most actually is above 5. There are few who are below. Okay, so that I like this situation mainly because I love to challenge people who are very confident in Python, because I had one situation where people just initially said like 8, 9, and then in a couple of sessions they said -2. But basically the Python is especially those who say 8, hopefully you already feel that there is ways how to see the Python code and think exactly what it does, but it does exactly opposite. So, and this is because the Python, the main reason why it is like that is the Python, it was the functional programming language and then made into the object-oriented programming language, and then it is totally not like let's say C++ type of languages with terms of the way how it executes code, but it is exactly like that in the memory management, and this is like really crazy combinations. But I will show you great examples then. I like the situation because sometimes when the course says, everybody says below 5, then it's not interesting. Now it will be interesting, okay? So we'll see. So okay, but let's start step by step, and maybe you already know that, but maybe not. So we need to quickly get everybody at the same line. So first, let's start by simple data types and complex data types. We will just in 1 hour get to the crash course in Python with the most important things, and then we'll also have a small task. Just in, let's say, 20 minutes, you'll need to do this now on the spot. I will help you. So simple data types, and we have complex data types. And this is the same for any programming language, including Java. And by the way, you already were in my lection, so you can basically, I don't know, do some other thing maybe, or anyways. But other people, please keep attention. I will try to do maybe make some new examples. Okay, so that's that. Let's then think some kind of examples about the asteroid game maybe. So let's see. So a number of asteroids, yeah, asteroids. So and this will be, let's say, 8 asteroids, and this is the integer data type. This will be the simple data type. You will see in a second, if you don't know at the minute like what means the simple and complex data types, but basically one data type is stored in stack memory, and other types of data types are called in heap memory in the RAM. And this is the truth for every single like programming language. Even JavaScript in browser works the same way. So and this is kind of important, because if we don't know the basics, there will be bad things happening later. So then let's say we can check is alive, true. This will be bool type. You can also cast. So what means casting is, let's say if I have is enemy. So hopefully I wrote it correctly. I can write like this, bool, and cast from let's say false, like that, and then it will be bool type, right? So still simple type, still everything like that. So, and please, online audience, if you're not ready to work now, then open Google Colab, as I said. Otherwise, just follow me along. I advise you to write the code, these small lines, rather than just skip them. Only if you're like, as I say, like very confident, then don't write it. But otherwise, please follow. So that's that. Okay, let's see next. Some kind of distance to sun. Let's see distance to sun in kilometers, how far it is. Distance to sun in kilometers. So this is 150 million kilometers, I guess. No. 92 million. So okay, let's try to write it. So this will be million. So there should be like that. Chick. Yep, and you can even add here these kind of underscores. This is also allowed in the Python. And I forgot to mention that in Python every single data type is kind of very large. So I think it's in 64 or 32 basically. So it's not a small number, not as like they don't have short integers and so on. So this would be like large number, but normally you would write large numbers different way. You would write it in this way, and then in deep learning you always write it in that way. So 90. So this will be 9296 e, and how many zeros? 6, 7 zeros, like that. So this is the way how you always write the numbers in Python. And now if you do this, it will be data type float. You can do the same also with the small numbers. Let's see. So the distance to ship. And this will be, let's say, some kind of very small number. So you can write 003, or you can write the same thing as e minus 3. And this is super common way how you will write any kind of numbers in Python. So that's that. Let's see if I have something on the chat. Okay, no questions. Great. So that's good. Let's move on. Okay, so then string. So there is a string as well. So player name. You can write your own name as well. So you can write the single quotes evals. And string data type is also a basic data type. There's also byte data type, but we don't care about that. So string data type is basic type for Python. It is not basic type for C language. And so the C language, this would be the complex data type. So that's that. Then let's see some of these complex types. So we'll see, let's say, what we could do with the lists probably. And let's think about what kind of list we could make. Lists are something like an array. Okay, distance is to enemies, yeah? So there will be different enemies, and there will be, let's say, 0.1 distance, 0.2, 0.3, 0.4, let's say, like that. So, and this is the list type, and you can also cast it, yeah? So list type, that's good. So, and you can add things here. So let's say if we add append a new distance here, and we can pop distance. There is also a del function, but please don't use it. This is not object oriented. So we can pop out the first one, and then so basically what happens after appending, you can also run this code just to make sure that it works. In a second, I will go in the live audience just to check that you don't have typos to help you to get it ready. So that's that. And then after here, you will get this kind of answer, right? This will be the output if you would print it. So that's that. So that's it. That is the first complex type. You can print it as well out if you want, right? Print like that, right? So. So that's that. Yeah. So I will have a quick question. It is much easier to do this question inside the live audience, but we can try this also in the online audience. So my question here will be, so I will copy one piece of code. Please don't write this code. Please honestly try to answer the answer, right? So for example, let's see. So first of all, if I write here len, so this is the length of these items, right? So just a second. Where's my notes? No, I know the sample, but I just want to. Where is? Oh shoot. Okay, here it is. Okay. Anyways. Oh yeah. Okay. I just want to tell Artis, yeah. please, Arti, play along. Okay. So I think you were in my course, right? Yeah. So don't don't ruin it this for others, right? So that's that I wanted to find, nothing else. Okay, so here, when you print out the answer, right? So first of all, let's everybody type in what will be the answer. What do you think? Like, online audience, this is just a dumb question. What will be the answer here? 4, yeah? 4 items, yeah? 4 items. You think 5 already? Okay, let's... There should be 4 actually. So if I run it, see, there is a 4 items there, yeah? So, but it's great that you're thinking along it. It's much better that you think along these things rather than, just ignore it and then at the end we have problems. Okay, so one of my question will be this. I will quickly post example, yeah, question, and then please do not try to copy this code in your with typing. Just write what you think. Just look at the code and think about it and type the answer, okay? So I want you to type the answer. So I will copy here, and please type the answer in the chat, or you in the live audience, think about it. I will ask in a second. I want you not to write this code. I want you to quickly type, let's say, in this case, if I would type, for example, 4,2, so this would be my answer. But I don't guarantee that this is the right answer. Think about it, write it. I will look myself on this. Please type in. And do not try to run it yourself, because I want to just explain a couple of things. Okay, so please do this quickly. Let's see who is typing in the chat. Nobody. So what is the answer? Please, please, please. I will not blame anyone for wrong answers. Just want to measure the temperature here. So no answers. Okay, what could be the answers? Let's think about it. So, what could be the answers? So we have that thing. So we have that thing. No. Okay, we have some answers already coming in. Thank you. I really appreciate those who honestly do not do monkey coding and just type in something. Okay, we have lots of different answers already. Okay, great. Thank you very much. I appreciate. There's we need to maybe update a little bit names in YouTube. It's otherwise difficult to follow, but really appreciate. We have all sorts of answers. 3-3, 4-2, 4-2. Yeah, I mean 4-2, 6-2. Any other ideas? So what is your Niels idea? Okay. Okay. So I believe nowadays, like at this moment, anyone who types probably already run the code, which is not really honest. But okay, let's see. Neil, why do you think this is 4 and 4?
Kad tu veic izmaiņas A, tad viņas arī tiek ieliktas B. Tāpēc. Un sākumā ir tas A kļūst par lista 4 un 5. Tad A pieliek 6, un kāds ir 3, bet arī B pieliekās klāt.
Okay, let me run and quickly show this. So basically, this was the measuring of temperature 4 and 4, and this in the live classroom already person started talking about this. So basically, this is the pointers, and the heap memory. I gave you already a lot of these hints. So heap memory means that anything is stored as a pointers, and nowadays, like you will see in a second. There's like lots of data types which all work in this way. So basically at this moment here, we actually do not copy any data from one list to the other list. We just copy the pointer to the list, and this is the same way how this works in any programming language and also with objects. Just to clarify that everybody is on the same line, because I saw that not everybody was on the same line, but I really appreciate that you were honest, those people who typed in the YouTube chat, because I know that it's easier to just not say what do you know or not know, but it's better that we all then learn. So basically the idea is here very simple. So you have the RAM, and you have the two parts of the RAM. So you have the stack memory, and you have the heap memory, stack and heap. Actually, let's do it a little bit down. So in the stack memory, you store the basic data types. In the heap memory, you store the complex data types, or in other words, the pointers. And usually they have, they are pointers, and I will not show here the lengths of the arrays or the zero delimiting character, but basically that's the same point. So here what it means is that on this side we have these simple data types, like there is 1, 2, 3, 4, 5, 6, I think we have there, right? And then there was the numbers inside there, 1, 2, 1, 1. Okay, this is interesting. Let's see if I can write. Yeah, I can write. Yes, 2, 3. So there's 8, 4, 5, right? And this everything is before that moment where we did the assignment. And on the oh man, why change the color? So okay, like this. And let's see, here we have these guys. So this will be in this color. Though now this time you didn't change my color. This is not cool. Okay, cool. So copy. Okay, we have it here. Right. So on this guy, this side we have the A and B. Yeah. So A and B. And here what we have is the assignment. So first A was covering this part. This was input of the A. Not the input, but the simple elements stored in the A. And we have the simple elements stored in the B. And at the moment when we did that assignment, what we did was actually telling that A now don't exist. So it says this, I don't care about this, and I'm assigning the pointer to the same list as here. So basically this one is pointing there, and this one is pointing there. And now what we have here is that if this was the C language, we would have a memory leak. So this part would not be released, but in the Python there is an automatic garbage collection. It will sometime release. Basically, if I would do this very quickly, I will still be able to crash the computer. Basically, if I would create a lot of memory leaks. So, and also you can notice here that the both ends of RAM come together, and if you play around it, you can also have the stack overflow and collisions in the middle. This is the way how hacking works, actually one of the ways. So, but yeah, this is something to keep in mind, and especially for those guys, there's a lot of people who did wrote 4.4. It means that you understand that part, but keep in mind that there's lots of objects, lots of complex types in Python. So let's jump into the next part. Okay, so we need to get to the task in, let's say, 10 minutes the most. So, so let's see. So there would be also some kind of dictionary, for example. So the dictionaries we could make in different ways. So let's say high scores. So high scores. And by the way, the dictionaries in Python is not ordered. This is one of the gotchas with people who think that Python very well. If you don't add ordered dictionary specific data type, it will not be ordered. It sometimes will give in the wrong order the keys. So let's see. So here let's write evals will have score of 100. Let's say Yanis will have score of 200, like that. So this is the dictionary. You can have values from dictionary by calling the key. Key cannot be the complex type. Key can be only a simple type that is hashable. So you can make complex types also hashable, but that's difficult. So print this one. We can also add the scores, right? So in the Python you cannot do this. You can only do this, and let's say add additional 20 points, yeah? So this would be that. Then what we could write, so we could write the score itself. So let's see. So string, score, as in, let's say, my, yeah? So, and there will be, let's say, score, 300, like that. And what I can do here, I can extract this 300 value using string functions. By the way, I will put all of this code quickly on the Jamboard. Just sorry, I will scroll a little bit so that everybody who is slower can get along with this. And literally in 8 minutes, we need to get to the first task that you can do online now. Okay, upload. So I'll put it here in the Jamboard. This is putting in the Jamboard so that everybody can follow later. Okay, let's see, new page. Okay, great. Okay, now we are here. Okay, so you can cut out things in Python and use actually there's very powerful ways how to work with the lists, arrays, and so on. We will use Numpy a lot, and Numpy has a really great ways how to work with the Python arrays. So first of all, let's see. So if I want to get the 300 score, so I could write here. So this would be let's say score, and I could have the this thing, and I could select. So this would be 0, 1, 2, 3, 4, 5, 6, 7, 7 till 8, 9, 8, 9, 10. So like that. I believe this should give me the score here. So this is the way how I can cut out the string, but this is not the only way. So there's much better ways. So string float, let's say integer, yeah, like that. And you can print out the score. Oops, like that. Run. Hopefully this works. Yeah, it works. So this is one option how to do this. In Python allows you to do this in many ways. So the same thing can look like this. So this is exactly the same thing. You can even do like this. So from -3 till 10, or you can do also like this. All of this is the same code, basically same output basically. So you can cut out from the other end, from the other end as well. From both ends, you can cut out the values. So basically, if I would select just so this would be just 0. So string last letter, yeah, would be something like this, -1. So I hope this is clear. If something is not clear, write me, but basically this is something we will use often, the way how Python works with lists and selecting the list values. So, so that's that. Okay, so that's good. Let's move on. So next thing, we will have lots of tuples as well. So tuples are like lists, but let me think about it. But they are also actually complex types, but they are unmodified. But they cannot be modified. So if I have a planet C, for example, here C, which will be displayed as a tuple with these kind of brackets. So these are used for mathematics and also for tuples. So then I cannot add anything here. So if I would add here append something, this will be error. So I cannot do this. This is very useful for making sure that basically the size of the arrays, this is useful and so on. We will use a lot of tuples. So these are unmodifiable items. So first of all, like where you can use it. One, maybe you have seen that in Python, you know how in Python use tuple to swap two variables or not? Okay, let's see. So if I have variable A, for example, 1, variable B, 2, and basically normally in any programming languages you would do something like this to swap these variables. So it would say temporary variable A, and then A equals B, and B equals temporary variable, right? So you forget about this. You can basically do this A comma B equals B comma A. So the tuples are very tricky because they are still complex types, but they behave when I use the equal operator a little bit different way. They actually try to copy values inside them. So this is again, that's why I'm saying Python is not that primitive. There's a lot of caveats. So but it's still a complex type. You can even write it like this. You cannot write it like this. So this is completely wrong. So because this way it means like mathematical mathematical brackets. To make it as a tuple, you need to do this, basically. So even you can write it like this. So there's a lot of funny ways how to write it. I want at this moment actually to show one more thing here. In Python, there is easily confusion with one thing. Okay, let's before that part, I have actually something interesting to show. I think I believe it will work. So again, let's do a quick question again. Please don't try to write this thing, because if you will do, then it will not be interesting. Let's say quick Python question. So let's say answer in chat. So I will pause this quickly. Please, you also think about it, look about it. So this is mostly for the people who think that they are in a Python, let's say 8.7.6, maybe maybe 8.7. So please try to answer this question without coding it quickly, just to check your own knowledge. So this is the question, and please answer what will be the printouts here. What will be the printouts? So this is regarding tuples. So this is the multiplication operation. Ideas? No ideas?
Nick, the first is a tuple, right? The first line. So it will raise an error.
Okay. Okay, we have some answer. In the class, people say that first one will be error. Okay, Somebody saying 2 and 4. Okay, great. Thank you for somebody interacting with me. Okay, I already have 2 likes at least. 4 and 4. Okay, good. More ideas. 4, 4. Okay. Thank you. Please. 4, 2. 4, 2. Somebody who is good at Python. I will not make fun of you, definitely 100%. I'm just wanting to measure the temperature here. Just 3 answers from the chat. We cannot just wait. Okay, 2 an error. Okay, cool. Thank you very much. So if the real answer, even without running, can tell you. So the real answer will be basically something like this. So this will be 2, 2 like this, I think, or it will be just in one array. On this will be 4. So let's run and see. I just want to illustrate there one thing here. Yeah, so see, this is a 2 and 2, so like that, and this is like that, and you can do the same thing. Basically, the first equation, first syntax. So this is the tuple, and multiplication in Python, when you do with the tuples or lists, means that it duplicates the whole input. It's like makes many times the whole input. You can do the same also with this, and it will produce 2 by 2 like that. And when you don't use correctly these brackets, then it changes completely the answer. So in this case, this is a mathematical bracket. In this case, this is a tuple bracket. So I also want to show you how this is often used. So if I have some function, so this is the Python functions, def means Python function, yeah. So, and if I want to have some kind of answer, yeah, so split in 2, yeah. So, and then there is an input, and then will be a part. So this would be input, let's say till len of input divided by 2. So those of you, do you know what this means? Do the 2 division signs? So this means the divide and floor. So again, in Python you can do this. So I'm just showing you that Python is very versatile. So and then return, you can do this, right? And in other programming languages it seems very weird, like how this is possible. Oh, right, by the way, I need to do this way. So yeah. So and if I then call this function print split in 2, let's say A, B, C, D, and run it, there should be 2 parts. Yeah, A, B, and C, D. So you please always understand that if you see functions with commas like that, it does not mean that there is 2 outputs. Yeah, this is the tuple. Okay, so tuples always does an outputs like that. So that's one thing to remember. Okay, so we'll take this one as well in the Jamboard. We'll move to the next example because we need to get to some actual task. Maybe if we don't get to the actual task, then there will be just a small homework, and next time we'll start making the computer game. I like making computer games. I had actually a computer games company some time ago. So that's that. Okay, great. So hopefully you learned something already, at least something, hopefully. So let's then, we have functions, we have the inputs, outputs. For functions, keep noticing here is a tab. This is the scope. So scope means in C language it would mean these brackets. See, we never use these brackets for scopes. We don't use them. We use tabs. Python loves tabs. Python is tab-based scopes. So, but also Python scopes do not really work. So I can give you some examples later, but not today. So let's do something interesting again. So let's see with some basic for loops. So if I would like to write some for loop, I could just write it here, right? But let's write it below somewhere. So let's see. Oh, maybe we could oh no, let's do something different. So okay, so let's write something. Okay, I will use maybe the same array of high scores. Yeah, let's do this maybe. Yeah, maybe. Let me think. What do I want to use it? No, I don't want to use it maybe. So let's do another so there will be high scores again. Let's make, because I don't want to talk about dictionaries yet. So if I make a new line, by the way, it creates tab like that. You can also write it in the same line. So evals, let's say score 100. Oh, not like that, like that. And Yanis scored 200. And then I can write the for loop, and I can write e in range, and range means this from 0 till len of this, yeah. And you can write the same thing also without 0. It will just go to the maximum value, and then I can extract things. So like name equals high score I, and then actually in this case it would be like, for example, 0, but this is bad way to write code. Never ever, please never ever write like this code. So I will just show you. So this is like score. So if I would do a code review, I would give this code that it needs to be rewritten, because you never ever in Python try to use indexes. Indexes are used only for actual data types like weights, matrices, features, and so on. Whenever you have something that is structured, you should use structured names. So what I mean by structured names, instead of writing code like that, you would write code like this: name, comma, score equals like that. So don't use like arbitrary like indexes. And then I can, let's say, print out these things, either name or so on, and it should work. So I can run this code, chick. Yep, it works. So better ways. In Python you can write better. So in Python you can write like this. You can write even directly in high scores, and it would also work. So this would be even better way to write the for loops. You can also reverse the order, for example. You can write reversed like this, and it will reverse order. You can also enumerate, like give numbers to these things, like enumerate, and then I can add here index, comma, like this. And it will give me the names in correct sequence, like 0, 1, 2, and so on. So this is super useful. All of these structures you should know by heart. They are very useful in Python. Some of these structures are even different from other programming languages and very helpful in Python. So Python is a great language where like even a preschooler can learn how to do Python, and professor can learn how to do Python. So I mean, like preschoolers use Python, and professors also use Python. So that's that. Okay, we have this one ready. Let's move on to another example. So let's try to make some kind of common way how to operate with arrays. So let's think. Okay, so we have this. Let's have the same array. This one I will just maybe copy it again down here. So, and I will add here another person. So this will be Peteris. Let's say 300. These are Latvian names. Okay, cool. So if I want, so my task is task to delete. Let's say, which I don't want to do something. So delete all users with score below 200. In Python, so this is not the task which I wanted to give you, but let's show you. So basically, those of you who know Python can do this in one-liner, one-liners are a little bit tricky, because if you do too much one-liners, I actually recently had one guy who was writing a serious complex mathematical code in line, which was like, I don't know, 300 characters long. Like this is very bad idea. First of all, please never ever write code in long spaghetti code, because you will not able to debug this code, and other people will be not able to read this code. This is a very bad idea to write long one-liners. But to write it like in a really dummy way to explain the concept, let me show you this. And this is also a pattern that is being used in any programming language. So I would go through the while loop len high scores, yeah. And I would check if so let's say, so let's extract this again the same way before, name score, high score chick. So if score is below 200, or maybe let's say equal 200, then I want to remove this item. By the way, if I would do this in a for loop, I will get an error there, because this is not the way how this should be done. So then E like that, and then if not, then I would just add plus E like that. So, and then afterwards I will have a list of just patterns like this. This will be the output. So, and this structure is a super common structure in any kind of programming languages, right? So we could even extend it. So below 200 and above 100. So if I write here and score larger than 100, this is the way how to write it. But in Python you can write even better. In Python you can write like this, and in other programming languages you cannot do this. So in Python you can write like this, 200, so score is below or equals 200, and like that. And this also works in Python. So this is the, and you notice that and, it looks like this. We don't use any kind of brackets around it. We use just and or, and we combine it like that. And we can also use, of course, let's say else if, else if, let's say score equals 0, then say print too bad, yeah. Something like that. So this is the way how to write it. By the way, comments, you don't need to write comments, yeah? So this is the while loops. And you can put loops in loops and so on, right? If any questions so far, write in the chat. We are trying to get everybody on the same line here. Okay, and I feel that we will not have the task live today, because we want to end up around 11, but we'll have some tasks for the home. But I'm trying to give you the most value in the time given here. Really appreciate anyone who writes the code, tries to do this. Actually, I've just realized I didn't go to check you. Like, no, it kind of works, yeah, to kind of understand. Okay, good. When we will have some kind of more complex mathematical things, then definitely let's sit down and check how this works. And if you send homeworks which do not work, like let's say there is some equation error, then we can look at together in the class, right? You just write me in the email or in the assignment, this doesn't work, I need help. Okay, and you will get a good score. Okay, I cannot give you 10 of that, but let's say I give you 7, right? But I see that you try to do this. We will look at this. We'll work together and find this.
Email?
No, in the Moodle, there will be the tasks. Yeah, but the email also works, but the Moodle will be fine. Okay, great. So this is that. Let's move on. What else? Okay, let's do some examples of the one-liners. Oh no, somebody is calling me. How can I? Okay, let's see. So some of the one-liners how to do in Python as well. I can do the same task of filtering, like let's say below 200 or above 100 with some other ways. And those people who know Python know this very well, but I can show you. So So let's see. So first of all, filter. There is a function filter which is built in, and if I pass in the high scores, I can use the lambda expressions. I think so. How it was? So I think it was like this lambda. So let me check. Maybe I wrote it wrong. Where is the? I usually don't use it in this way. That's why I'm a little bit confused. So okay, let's open it. Name score, and if score. So the below I don't want, so I want above 200, yeah? Hopefully the order is right. Maybe the order is not right. Let me run it, just a second. Oh no, it is. No, it is. Is it right or? Okay, it's not printing, print. Let's see, run. Just a second, we'll get through this. I usually write it in a different way, just a second. Have not used filter for a while. Just a second. Okay, lambda is the first one. Right, I wrote it in the wrong direction. So like this, chick. Okay, run, it should work. Okay, the filter object, and if I cast it to the list, it works. So chicks. So the filter, oh, just a second. So the filter object is because it's an iterator. So missing, name, scores, what I did wrong. Lambda, maybe, I know. He don't like that I didn't put these things, I think. Whoa, what is that? Tuple parameter unpacking not supported in Python 3. Okay, great. I made myself a fool of here, but okay, let's say IT. So this will not be nice. That's why I'm saying the one-liners are not cool. So in this case, I cannot say what is the score, but it will work. Yeah, it works. So I cannot unpack it in lambda function. So this is one way how to do this. Not very nice code. Much simpler way how I usually do this is something like this. So this will be let's say name score name score in high scores if score above 200. Yep. So this is much nicer way, but still spaghetti. So spaghetti code is not preferable, but I just wanted to show you how to do this in some of the one-liners. So Python is very powerful of doing things in one-liners, but as long as you make it very explicit variable names. Please never try to do these ones like and so on, ones, zeros, indexes. And I had literally situation where Ukrainian programmers, basically they are actually the same programmers from Soviet times where they optimized the nuclear strike to the west. Actually, these were those kind of guys. They built very difficult mathematical model for analytical chemistry, and they use variable names A, B, C, D, E, F, G, and then when there is alphabet N, there is Z1, Z2, and then there was a bug. And then this guy sit 2 weeks to try to understand what was the problem. So basically, this is very bad idea to use meaningless variable names. Variable names must be as long as possible, as detailed as possible. The code must be as self-explanatory as possible. Basically, comments are worse than having the code which is clean. Like you don't need to optimize your code for readability. Instead, the compiler and the interpreter will optimize it. There are, of course, cases where when you wrote, for example, software programs for Wi-Fi routers, then you need to optimize code yourself, right? C++ code, the C code. But in these cases, never optimize code. Try to make it as readable as possible. Okay, that's that. I think we got through these examples. Let me check if I have some, what will be these tasks and some of the example. Okay, yeah, let's work a little bit with matplotlib and, oh no, with classes. I forgot about the classes as well. So yeah, so let's see. So the class structures. We have a little bit of time left, so let's class structures. So class. These are also object-oriented, like these are objects, complex types. These are not simple types, yeah? So if we look here, let's make, you will have similar structure actually at home for this. So this will be the game object, for example, object, and this will be def, and there, this is not int, this is init, yeah? And here we'll have super, yeah, and then we'll call int here. So this is the constructor, and the variables, right, the member variables, you write inside the constructor. You please do not write variables here. So I will maybe next time explain, those of you who think that you're Python 8, 7, even you, I believe I can fool a little bit with these, but maybe not. Maybe you already know these things. But basically, don't write the variables here. Like let's say we could write here lives. Yeah. So 3. This is wrong. This will be a static type, and there are ways how to hack around it. But this is not normal Python way to write variables. So instead, variables are written here. Self lives 3. And then if I'm creating the game object, so I have, let's say, object 1, game object, you already start seeing some problems. So first of all, the Python object creation or instance creation looks exactly the same way as a function call, which is really annoying because there is no new or game object, it's just game object. So this already means please use always class objects as a large letters in a Pascal case. So this is the notion there. And then for the functions, there's actually, so let's say def, bump, I don't know, let's say like that. So this will get lives -1, and so we could even have some, let's say, parameters here as well coming in, let's say the number of bumps, and by default 1, and then we can use this like that. So the functions also always need to have the pointer variable as the first variable. This is coming from the functional programming languages, and there's no way around it. You need to do it in this way. If you don't do it in this way, this will be again static functions. So you have 2 game objects, and if I call the other one bump, yeah, bump, and let's say 3 times, yeah, so there will be 2 different lives, yeah, object 1 lives, object 2 lives, yeah. I really hope that if I will tell you this, yeah, if I will show you this, that object 1, so let's say object, let's say, so, okay, this will be the same. So if I bump the other one, let's say 2 times, object 1, and if I've then store the value here from the object 1, this will be the same situation as before with lists, okay? Understood that these are complex types. The object 1 will not copy variables from object 1 to object 2. They will just copy the pointer of the whole structure. So this is important to understand that this is the same complex type copying pointer, yeah? And if I would like to copy each structure of the data, I would need to use special function that copies each element of simple type, or write my own clone function, for example, it's not nothing against that, but this will not work like copying data, okay? And this is the same for every single programming language. This is not something specific to Python. So in this case, there will be answer. In one case, this will be answer 1. In another case, there will be answer 0. So this is the kind of basic structure of the Python object, but this goes further. So there are 3 things in object-oriented programming which needs to be taken account for. One is the, let's say, class player. So this is the inheritance, yeah. So inheritance. So we can inherit the parent class, yeah. So we inherit the parent class, and we can write here some specific values to the player. So there will be, let's say, score, yeah, score, and we can inherit the same object from another. For another child, this will be, let's say, alien, and alien will have what it also, we could have also here rockets maybe. What we could have here is the, okay, let's have rockets here. So rockets, jigs, and each of these will have different now the different variables, but we can instantiate them the same way, like this, and then we can also even change the name. So this will be the player, will be the alien, and both of them have lives, but the player have also the score, yeah, like that. So I will put this on the Jamboard quickly and show 2 other things that we need to take into account with regards to objects, and then I think we'll wrap up today. We'll show a little bit for what's for the homework. And next week, I'm not sure if we will be able to do this next week because I will be in America, but I will check if it's not like in the middle of the night, maybe we can do this remotely. Otherwise, then week after, we'll do this. This will be linear algebra, so I will add some materials to look up, but this will be Numpy and matrix multiplications, basically. And it will be literally that you can draw the triangle, and then using the matrix multiplications, you can rotate it around, for example, right? It will be very practical. You will use very simple mathematics to move around triangles, objects on the game. It will be quite complete game actually by the next time. So that's kind of cool. So this will be that, but it will be object oriented with all of these features. That's why I'm talking about this today. So you know how to code. We talk in everybody talks in the same language, right? And then next week we will have the mathematical language as a basis. So that's that. Okay, so what else we need? We need encapsulation. So this is inheritance. This is called inheritance. Inheritance. You need also encapsulation. So let's say here encapsulation. So we could have it starting from, okay, let's start here. Encapsulation. And encapsulation will have something like this. So secret bonus, yeah. Bonus. And you see the way how I write variables, this is also kind of important. You use small letters, underscores, and so on for variables and function names. This is also Python typing convention. So, and this underscores, actually 2 underscores, means private. This is strange that in Python there is no keyword private. There is just private variable names. So def get secret bonus, yeah, and this will be getter, and then there will be have setter. You can also have properties, but this is in Python this does not look nice at all. So in some other languages, let's say Java, C#, you can have nice properties. In Python it's even better to just write it like this. Secret bonus, and then I can set it right like this, and then I can access it. So alien print secret bonus, but I cannot access the, so this will not work. 2 underscores secret bonus, it even don't show up here. So this is error. So this is the encapsulation. Oh. This is encapsulation. And the last thing we need to look at is the polymorphism. So polymorphism means that we don't care what kind of object we are working with as long as it has the necessary functions. So this is very nicely done in C++ language, where we can have the pure virtual functions. Just bear with me, I know it's 11, a little bit. Let's show couple of things here and explain one more thing about matplotlib, and then we can end up maybe in, let's say, 10 minutes more. Okay. So I need to actually look if my calendar is not already having the problems. Okay, it is having the problems. Okay, let's see. I will need to. I will write message to my partners that I will be a little bit late. Just a second. Okay, let's see. So, okay, so the polymorphism looks something like this. So, if I have, let's see, so the alien player, right, object, it can be attached in any part. So I will import ABC, which is the abstract library, and also I propose that you, when in a homework, when you use the matplotlib and Numpy, you can import matplotlib like this and Numpy like this. Just give you a quick example at the end of this lecture how to use those things. You can explore yourself at home, and then next week we will explore it properly together. So that's that. We'll add it here. So, and then how this works is with this ABC, so I could write the interfaces. So class, interface, attacking object. Let's say attacking. So, and this will be ABC, and it will be inherited from ABC. And then I will create a function. So this will be like fire. Let's fire rockets or something. And I will use pass, which means just an empty function. And then I will add a function decorator, which is, we will talk about this maybe later. So this is abstract method. And if I would try to instantiate this myself, I would create like attacker like this. It will cause an error. You cannot do this. But instead, what you can do this, once you can, if I move this a little bit lower so everybody can see it, I can add this to any kind of objects. Like I can add it even to the base object or here like this, and then if I will create a player without method fire, it will give me error first of all. So, but I need to add it, so there will be fire. So this will be print fire. Like this, right? And then also here, fire, yeah? And the interesting thing about this kind of polymorphism structure is that I can then later don't care what kind of objects I'm working with. Is it the player? Is it the alien? Is it, let's say, even some kind of tank from other game? Whatever. As long as it has the function fire, this is something that I need. So this would be like a polymorphism in a super nutshell. So that's that. Okay, I just want to show you a little bit. I will quickly create a new file about the Numpy and matplotlib. So a live file, another one. So the last thing in last minutes. So So first of all, as we talked about the data types, there's also different data types in a numerical format. So the most common, which we will use a lot, is Numpy. So for example, if I have here the score rating, yeah, and I have the, let's say 200, 300, let's say then 150, 500, yeah. So this is the list type, yeah. We can convert list type into this other type, which we will use a lot next week, which is the, it is actually always called as NP. So, and pyplot as PLT. So, and here Numpy array like this, right? We can cast it or use it like this, and this is a different type. This will be now NP array. And this will be the same effect. If I would multiply, let's say, all of this by 2, it will create 2 instances of lists, and in this case it will just so this should be NP in front, so I have something different. In this case it will just have everything like 400, 600, and so on. So this is mathematical. So Numpy is very mathematical. It has all of the operations mathematical, and in this case it will be just typical Python lists where will be like copies, right, of pointers, whatever. So copies, yeah. So the Numpy arrays are very powerful. We will look at them next week, but I'm just highlighting them already, so you can start playing around with them in the homework. So plot will have a function plot, which will just visually plot the values. You can plot both values basically. I can plot also this one, except let's comment out this one, and then you can show this and there is a lot of nice functions. So how it looks like, if I run like this, so it plots the visually, but it's interesting that it did not plot the other one. Okay, maybe the color, no. Wow, yeah, no, but they should not. Yeah, I know why it's not different. So I wanted to do this actually. Check, raise 2, and now it will have 2 lines. So, now it will have 2 lines. So yeah, and you can also make it visually as you want with colors and so on. Like, you can just need to play around this plotting library. Plotting library is great. You can have the, have different types what you can do here. So you can also have the, I think it was color and style you can add here. Let me see. So what was the way how there's formatting options. I need to show a couple of things and then we'll end. Formatting options. So yeah, there is okay. You just write it in like this. So there is a red. So and then this will be a green, and then we can have this one as a line and this one as a dotted line. There's a lot of nice ways how to format this. So you run it, and great, we have it like that. So that's that. So this is a plotting library. The one thing about Python lists and Numpy arrays, there is a reason why you still want to have lists in the machine learning world. So for example, if I want to add here additional element, then if I want to add additional element to Numpy array, this is really pain. So adding additional elements in Numpy array, so it means something like this: np concatenate, and then you add existing, and then you create, let's say, 600, and then you have axis 0, and then you have added. Huge pain. This is not the way how normally you should done it. So normally how you could do this is just by using something like this: convert back to the list, append element, and then convert back to the Numpy. Clear? So that's why I'm saying the basic, like not basic, but those complex data types, they are still super useful also in like daily work. So we don't get rid of lists. Even if we have this super powerful Numpy array, we still use lists very often. So that's that. Okay, so I think this will be enough for these homework tasks. If something is not clear, then write me. I think the next lection will be really interesting when we can look at what you have done and what you know, what you don't know, and then also update yourself, please, on the linear algebra tasks. So I think that's it for today. Let me check if I have some questions in the live session. So we scored 3 likes. We have 19 alive. That's great. 19 people still alive. So okay, let me give you a goodbye here. So let's meet you again either next week or week after. Please follow the Moodle. I will try to meet everybody also in person in time to time. Cannot guarantee always, but we'll try to do this. Okay.